October 19th, 2017, 3 a.m. Hawaii Standard Time. Robert Weryk, a postdoctoral researcher at the University of Hawaii, is doing what postdocs do, sifting through telescope data while questioning his life choices. He's looking at images from PanSTARRS, the Panoramic Survey Telescope and Rapid Response System, searching for near-Earth asteroids that might kill us all. Then he sees it. A single point of light moving impossibly fast, too fast, 26 kilometers per second fast. That's 58,000 miles per hour. That's leaving the solar system forever fast. Weryk runs the calculations, checks them, runs them again, calls his supervisor. They check together. Then they both sit in silence, staring at numbers that shouldn't exist. This object didn't come from the asteroid belt. It didn't come from the Kuiper belt. It didn't come from the Oort cloud. It came from outside. For the first time in human history, we had detected an object from another star system passing through our own, an interstellar visitor, a cosmic immigrant, a piece of another world, possibly another civilization, flying past Earth at speeds that made catching it impossible. We named it Oumuamua, Hawaiian for scout, or messenger from afar arriving first. That was our first mistake. You don't name something Scout unless you're expecting an army to follow. Then we studied it, and that's when things got weird. It was shaped like nothing we'd ever seen, 10 times longer than it was wide. A cosmic cigar, a space needle, a ship. It was tumbling, but not randomly. It had a specific rotation every 7.3 hours, like it was stabilizing itself. It had no comet tail, despite passing close to the sun. No outgassing, no ice. Just metal, rock, something else. Then, as it left our solar system, Oumuamua did something that broke every law of celestial mechanics we thought we understood. It accelerated, not from gravity, not from outgassing, not from any force we could identify. It just sped up, like something was pushing it, or pulling it, or like it was pushing itself. The scientific community lost their collective minds. Papers were published, theories were proposed. Most were rejected. One couldn't be dismissed. What if Oumuamua wasn't natural? Professor Avi Loeb, chair of Harvard's Astronomy department, not some YouTube conspiracy theorist, the chair of astronomy at Harvard, published a peer-reviewed paper suggesting Oumuamua might be artificial, alien, manufactured. The scientific establishment went from losing their minds to eating each other alive. By the time we figured out what we were looking at, Oumuamua was already leaving, accelerating into the darkness, beyond our reach, beyond our understanding, taking its secrets with it. Tonight, we're going to spend some minutes exploring the object that changed everything. The visitor that might have been visiting. The scout that might have been scouting. The natural phenomenon that behaved unnaturally. Was Oumuamua just a weird space rock? Or was it humanity's first contact with alien technology? And perhaps more terrifying, if it was artificial, why didn't it stop to say hello?
All right, my cosmically curious friends, skeptics who click for debunking and believers who click for validation, welcome to minutes of the most controversial object to enter our solar system since Pluto lost its planetary status. Before we dive into the mystery that broke astronomy Twitter worse than the black hole image, let me set the stage for what we thought we knew about interstellar objects before Oumuamua showed up and flipped the table. What we expected versus what we got. For decades, astronomers knew interstellar objects had to exist. The math demanded it. The predictions? The galaxy is full of rogue planets, asteroids, and comets. Gravitational interactions eject objects from star systems. These objects wander interstellar space. Some must pass through our solar system. We should see 1 to 2 per year with modern telescopes. Scientists had it all figured out. Interstellar objects would be basically like our objects, but from somewhere else. Probably icy, definitely following predictable paths, certainly not accelerating mysteriously or shaped like cosmic cigarettes, or potentially being alien probes. That wasn't in the models. The night everything changed. Let's talk about what actually happened that October night. 3 a.m. Weryk notices unusual object in Pan-STARRS data. 3:30 a.m. Calculates preliminary orbit, hyperbolic, leaving forever. 4 a.m. Checks previous night's observations. 4:30 a.m. Confirms this came from interstellar space. 5 a.m. Begins calling colleagues. 6 a.m. Multiple observatories alerted. By noon, the entire astronomical community is freaking out. Within 24 hours, every major telescope on Earth that could see Oumuamua was pointed at it. Hubble cleared its schedule. The VLT in Chile went into overdrive. Radio telescopes started listening for signals. It was like cosmic paparazzi discovering an alien celebrity. The trajectory that broke brains. Oumuamua's path was unlike anything we'd seen. The approach? Entered from above the ecliptic plane at 26 kilometers per second, came from the direction of Vega approximately, passed within 0.25 AU from the Sun, closer than Venus, crossed Earth's orbit in October 2017. It was already leaving when we spotted it. We almost missed it entirely. This object had been in our solar system since at least 2015, possibly earlier. It passed closest to the Sun on September 9, 2017. We didn't notice it until October 19th, when it was already 33 million kilometers from Earth and heading out. We had been cosmically photobombed and didn't even know it. The shape that shouldn't be. Here's where things get weird, and by weird, I mean questioning everything we know about how objects form in space weird. Oumuamua's dimensions: length, 400 to 800 meters, we're not sure. Width, 40 to 80 meters, definitely thin. Aspect ratio, 10 to 1, unprecedented. Shape, cigar, pancake, disc, massive debate. Rotation, tumbling every 7.3 hours. Natural objects don't form like this. Gravity likes spheres. It tolerates slight oblongs. It doesn't create space cigars. The brightness mystery. Oumuamua's brightness varied by a factor of 10 as it rotated. That's huge. That means it's extremely elongated, the cigar theory, it's flat and we're seeing it edge on sometimes, the pancake theory, or it has extreme variations in surface reflectivity, the disco ball theory. Possibility 4, classified by scientific consensus. Narrator, that fourth possibility, that's the one where it's artificial and the varying brightness is from solar panels or antenna arrays or alien hull plating. But we don't talk about that in polite scientific company. That gets you uninvited from conferences. The color that told us nothing. When astronomers analyze an object's spectral system, it usually tells us what it's made of. With Oumuamua, the spectral analysis, slightly reddish, like long exposed space objects, no spectral lines indicating composition, no water ice signatures, no organic compound signatures, no mineral signatures we recognized. Basically, shrug emoji. It was red. That's all we got. Red like objects that have been in space for millions of years getting cosmic sunburn. But red doesn't tell us if it's rock, metal, or the hull of an alien probe painted with space-resistant rust-colored paint. The acceleration that broke physics. In June 2018, after months of careful observation, astronomers announced something that shouldn't be possible. Oumuamua was accelerating away from the Sun faster than gravity alone could explain. The numbers? Excess acceleration of 0.001 meters per second squared. Small, but definitely there. Not explained by solar radiation pressure, too small, outgassing, no visible coma, magnetic forces, not strong enough, gravitational assists, wrong direction. When physicists say something can't be explained by known physics, they don't mean it's magic. They mean either we're missing something obvious, we're seeing something new, or we're seeing something artificial. Guess which option certain Harvard professors preferred?
Let me introduce you to Professor Abraham Avi Loeb, former chair of Harvard's Astronomy Department, published over 700 scientific papers, received millions in research grants, advised multiple governments on space policy. Not a crackpot, not a UFO enthusiast, a serious, respected scientist who thinks Oumuamua might be alien technology. The paper that started a war. In November 2018, Loeb and his postdoc Shmuel Bialy published a paper in the astrophysical journal Letters titled, "Could Solar Radiation Pressure Explain Oumuamua's Peculiar Acceleration?" Buried in the calculations was this bombshell: Oumuamua might be a light sail. A light sail, as in a manufactured object designed to be pushed by starlight, as in technology, as in aliens. The scientific community's reaction was swift and brutal. The light sail hypothesis. Here's Loeb's argument. For Oumuamua to accelerate from solar radiation alone, it would need to be extremely thin, less than 1 millimeter, extremely large to catch sunlight, extremely light to be pushed effectively. Exactly what a light sail would be. What a coincidence! The first interstellar object we detect just happens to have the exact properties needed for an alien light sail. It's like finding a wheel in nature and saying, well, round rocks exist, so this is probably natural. The uncomfortable coincidence. Here's what really got people thinking. In 2016, Loeb was advising Breakthrough Starshot, a $100 million project to send light sails to Alpha Centauri. The design specs for those sails? Breakthrough Starshot sails. Thickness, less than 1 millimeter. Shape, flat or slightly curved. Material, highly reflective. Acceleration by solar or laser radiation. Oumuamua's required properties? Thickness, less than 1 millimeter to explain acceleration. Shape, flat or curved to explain brightness variations. Surface, reflective, observed. Acceleration by solar radiation, observed. So either Oumuamua is exactly like the light sails we're planning to build by pure cosmic coincidence, or it is a light sail that someone else already built. The implications, if true. If Oumuamua is artificial, then immediate implications, we're not alone. Interstellar travel is possible. Other civilizations exist, or existed. They use similar technology to what we're developing. They either didn't notice us or didn't care. Bigger questions. Why didn't it stop? Why didn't it signal? Is it dead technology? Is it active but ignoring us? Was it targeted at our solar system? Is it a probe or just debris? The idea that Oumuamua might be alien technology isn't just about aliens. It's about us, about our cosmic loneliness, about our desperate need not to be alone, about our fear that we are alone. The scientific establishment strikes back. The response to Loeb's hypothesis was not kind. The criticism? Irresponsible speculation. Extraordinary claims require extraordinary evidence. Damaging to serious SETI research. Publicity seeking. Unscientific. The critics? Most of the International Astronomical Union, many of Loeb's Harvard colleagues, science journalists, other SETI researchers, ironically. Scientists who spend their careers looking for aliens got mad at a scientist for suggesting we might have found evidence of aliens. It's like firefighters getting angry at someone for pointing out smoke. Loeb's defense. Loeb didn't back down. His arguments? Conservative science is killing wonder. We need to be open to possibilities. Dismissing evidence because it's uncomfortable is not science. The data doesn't lie. Oumuamua's acceleration cannot be explained by conventional means. We must consider
all possibilities. The Fermi Paradox solution. If the galaxy is full of civilizations, their artifacts should pass through our solar system. Oumuamua fits. The plastic bottle analogy. If you're walking on a beach and find a plastic bottle, you don't assume it formed naturally just because you didn't see who made it. Loeb asked a simple question. If we saw Oumuamua's properties in an object we knew was artificial, would we have any doubt? The answer is no. We'd immediately recognize it as technology. The only reason we resist is because it came from space. The desperate alternatives. Scientists scrambled to find natural explanations. Hydrogen, iceberg theory. Oumuamua is made of frozen hydrogen. Invisible outgassing explains acceleration. Problem: should have evaporated completely. Dust bunny theory. Oumuamua is a fluffy aggregate of dust. Low density explains radiation pressure. Problem: should have been torn apart by tidal forces. Nitrogen ice theory. Chunk of nitrogen ice like Pluto's surface explains lack of visible outgassing. Problem: requires very specific origin. Every natural explanation requires Oumuamua to be something we've never seen before, made of materials we've never observed, behaving in ways we've never witnessed. But sure, that's more likely than it being artificial. Because reasons.
Let's get into the hard science of why Oumuamua drives physicists to drink. Not socially, alone, in their offices, while staring at equations that don't balance. The acceleration problem in detail. When an object passes through our solar system, it should follow a predictable path based on forces acting on space objects. Gravity, primary force, solar radiation pressure, tiny for most objects, outgassing thrust for comets, Yarkovsky effect for rotating bodies, magnetic forces negligible usually. For Oumuamua, gravity, check, calculated correctly. Solar radiation, too weak unless it's a sail. Outgassing, no evidence whatsoever. Yarkovsky, wrong direction. Magnetic, not nearly strong enough. The acceleration was there. We measured it multiple times with multiple telescopes. It's not a measurement error. Something pushed Oumuamua. We just don't know what. The missing comet tail. Here's the big problem with the "it's a comet" explanation. What comets do near the sun? Ice sublimates, turns to gas. Gas forms a visible coma. Solar wind creates a tail. Outgassing provides thrust. We see all of this. What Oumuamua did? No visible coma, no dust tail, no ion tail, no spectroscopic evidence of gas, but still accelerated. It's like finding a car moving without an engine, wheels, or any visible means of propulsion and insisting it must be a normal car because what else could it be? The size paradox. If Oumuamua was outgassing enough to accelerate, required mass loss, about 10% of total mass, should create huge visible cloud, detectable from Earth easily. We saw nothing. Upper limits from observations, less than 1 kilogram per second of dust production, 100,000 times less than typical comet. Invisible outgassing, impossible at these levels, unless it's not outgassing at all. Spitzer Space Telescope, one of our most sensitive instruments, looked for heat from Oumuamua and found nothing. Either it's smaller than we think, more reflective than we think, or colder than we think, or all three, or something else entirely. The shape that physics hates. Let's talk about why Oumuamua's shape is impossible. How natural objects form? Gravity pulls material together. Rotation creates a slight oblation. Maximum aspect ratio, about 3:1. Anything longer, breaks apart. Oumuamua's aspect ratio, minimum 6:1. Possibly 10:1, maybe even 20:1.
if disc-shaped, tumbling without breaking. For Oumuamua to maintain its shape while tumbling, it would need tensile strength like metal or carbon fiber. Rock that elongated would snap like a breadstick. Ice would shatter. Unless it's not rock or ice. The tumbling that's too perfect. Oumuamua's rotation is weird. The tumbling, period, 7.3 hours, very specific. Non-principal axis rotation, excited spin state, should dampen over time, appears stable. What this means? Either it was recently disturbed, unlikely, or it's maintaining the spin, how? Or it's shaped to tumble this way, designed, or we're missing something fundamental. Objects in space don't maintain excited spin states for millions of years. Energy dissipates, rotation stabilizes. Unless something is actively maintaining the spin, like reaction wheels or gyroscopes or other technologies we associate with spacecraft. The approach that's too convenient. Oumuamua's entry into our solar system is suspiciously optimal. The trajectory, entered from above the ecliptic, perfect angle to survey all planets, passed close to the Sun, gravitational assist, crossed Earth's orbit, exited with maximum velocity gain. If you were programming a probe to survey our solar system efficiently, this is exactly the trajectory you'd choose. Maximum observation opportunity, minimum travel time, free gravitational boost on the way out. It's almost like it was planned. The velocity that's too slow. Here's something that keeps astronomers up at night. Oumuamua entered our solar system at almost exactly the local standard of rest, the average motion of stars in our neighborhood. Why is this weird? Most objects have random velocities. Being at LSR is like floating in a river. It requires specific conditions or deliberate positioning. It's like finding a bottle floating in the ocean that's perfectly stationary relative to the average current. Possible? Yes. Likely? No. Suspicious? Absolutely.
Let's go through those crucial 40 days when humanity scrambled to study our first known interstellar visitor before it disappeared forever. Day 1, October 19, 2017. The Discovery. Timeline. 3 a.m. HST, Weryk spots unusual object. 6 a.m., orbit confirmed as hyperbolic. 9 a.m., minor planet center notified. 12 p.m., designation A/2017 U1 assigned. 3 p.m., other observatories alerted. 6 p.m., confirmation observations begin. Within 15 hours of discovery, Oumuamua went from unknown to the most important object in the solar system. Every telescope that could see it was preparing to look. Day 6, October 24, the media frenzy. What happened? NASA announces first interstellar object. Media goes absolutely insane. Alien object headlines everywhere. Scientists try to calm everyone down. Nobody listens. Actual CNN headline. Mysterious object from deep space baffles scientists. The media took "We found our first interstellar asteroid" and turned it into "Aliens are here and scientists are baffled," which, to be fair, turned out to be more accurate than anyone expected. Day 8, October 26th, the shape revelation. European Southern Observatory's Very Large Telescope makes detailed observations. The discovery. Brightness varies by factor of 10, indicates extreme elongation, unlike anything in our solar system. Scientists genuinely baffled now. This is when astronomers started sweating. A normal asteroid should vary by maybe 20–30% in brightness. Oumuamua varied by 1,000%. That's not normal. That's not even abnormal. That's the universe is trolling us level weird. Day 10, October 28th, the naming. The name Oumuamua, chosen by Pan-STARRS team. Hawaiian, scout or messenger. First character is Akina, not an apostrophe. Pronunciation, Oumuamua. They named it Scout.
Not visitor, not wanderer, but scout, like they subconsciously knew it was doing reconnaissance. The Hawaiian elder who suggested the name later said he felt compelled to choose it. Day 15, November 2nd, the SETI observations. Breakthrough Listen starts monitoring Oumuamua for radio signals. The search, Green Bank Telescope, 100-meter dish, frequencies 1 to 12 gigahertz. Observation time, 10 hours. Sensitivity could detect cell phone transmission. Results, nothing. No signals, but absence of evidence isn't evidence of absence. If it's a dead probe, it wouldn't transmit. If it's using communication we can't detect, we wouldn't hear it. If it's deliberately silent, well, that's even more concerning. Day 20, November 7th, the composition mystery. Multiple telescopes tried to determine what Oumuamua is made of. The results: no water ice signatures, no organic molecules detected, no mineral identification, slightly red color, space weathering. Basically, we have no idea. Every asteroid and comet we've studied has distinctive spectral signatures. Oumuamua had none. It's like trying to identify a car by its color alone, except the color is vaguely reddish, maybe grayish, we're not sure. Day 25, November 12, the origin puzzle. Astronomers trace back Oumuamua's path. The back calculation came from the direction of Vega, but Vega wasn't there when it left. Travel time, hundreds of thousands of years minimum, maybe millions. Original system, unknown. Oumuamua had been traveling for so long that its home star had moved. It's like getting a letter with no return address, postmarked somewhere, sometime, from someone. Very helpful. Day 30, November 17th. The Hubble joins the hunt. Hubble Space Telescope observations. What Hubble saw: confirmed tumbling motion, refined size estimates, no coma or gas outing, object already very faint, time running out. Even Hubble, our sharpest eye in the sky, could only see Oumuamua as a point of light. We were trying to study an object the size of a skyscraper from 200 million kilometers away. It's like trying to read a book in New York from Los Angeles, in the dark, while the book is spinning. Day 40, November 28th, the last good look. Final observations. Oumuamua now too faint for most telescopes, moving away at 95,000 kilometers an hour. Will never return. Humanity's window closes.
After 40 days, our first interstellar visitor vanished into the darkness. We had 6 weeks to study an object from another star system, and we spent half of it arguing about what to call it and whether to panic.
In the years since Oumuamua left, scientists have proposed dozens of theories to explain it. Let's go through them, from the boring to the mind-blowing to the "did you seriously publish that?" Theory 1. It's just a weird rock. The basic rock hypothesis. Unusual shape but natural, formed through collisions, elongated by tidal forces, tumbling from recent impact. Nothing special except origin. Problems? Doesn't explain acceleration, shape too extreme for rock, no known formation mechanism, should have broken apart. Too many coincidences. The weird rock theory is science's version of nothing to see here, move along. It explains nothing, but makes everyone feel better about not having explanations. Theory 2. Hydrogen iceberg. The H2 ice theory, Seligman and Laughlin, 2020. Oumuamua made of pure hydrogen ice, formed in giant molecular cloud. Hydrogen invisible when it evaporates. Explains acceleration without visible tail. Could survive interstellar journey. Problems? Should evaporate too quickly. Never observed such objects. Formation mechanism unclear. Requires perfect conditions. Conveniently invisible outgassing. This theory requires Oumuamua to be made of something we've never seen, formed in a way we don't understand, surviving longer than physics suggests, and evaporating in a way we can't detect. But sure, more likely than aliens. Theory 3. Nitrogen ice chunk. The N2 ice theory. Jackson and Desch, 2021. Chunk of nitrogen ice like Pluto's surface, knocked off by impact. Nitrogen evaporates invisibly. Explains acceleration and shape. Natural, but rare. Problems: requires very specific origin. Should be extremely rare. First object we see is this rare thing. Statistical unlikelihood. Still doesn't explain all properties. The odds of the first interstellar object being a rare chunk of nitrogen ice knocked off a Pluto-like planet are astronomical. It's like your first lottery ticket winning the jackpot. Possible? Yes. Likely? No. Theory 4. Dust bunny in space. The fractal aggregate theory. Oumuamua is loosely bound dust, like cosmic cotton candy. Very low density, large area for radiation pressure. Explains acceleration naturally. Problems: should be torn apart by tidal forces. Never seen anything like it. How does it maintain shape? Tumbling should destroy it. Violates material strength limits. This theory asks us to believe Oumuamua is held together by hopes and dreams while tumbling through space at 95,000 kilometers per hour. Physics doesn't work that way. Neither does hope. Theory 6. Dark comet. The dead comet theory. Old comet that lost volatile materials, covered with non-volatile crust. Tiny jets we couldn't see. Explains most properties, relatively mundane. Problems: no comet this elongated known. Acceleration still hard to explain. Why completely inactive? Spectroscopy doesn't match. First interstellar object is dead comet? A comet that doesn't act like a comet, look like a comet, or behave like a comet, but is definitely a comet because what else could it be? This is astronomy's version of "the dog ate my homework." Theory 7. 11 probe. Theory 7. Light sail. Artificial. The alien technology theory. Loeb. Artificial light sail. Deliberately or accidentally visiting. Explains all weird properties. Consistent with physics. We're building similar technology. Problems: extraordinary claim. No radio signals. Why tumbling? Why no course correction? Occam's razor says no. The light sail theory actually explains Oumuamua's properties better than natural theories. It's just that accepting it means accepting we're not alone, and apparently that's scarier than bad physics. Theory 8. Alien probe. Active. The active reconnaissance theory. Functioning alien probe. Surveying our solar system. Tumbling is camouflage. Acceleration was course correction. Silent to avoid contact. Why this could be true? Optimal trajectory for survey. Timed when all planets were visible. Acceleration at perfect moment. Shape optimal for sensors. Left quickly after observation. If Oumuamua was actively surveying us, it did a perfect job. It saw all our planets, sampled our solar wind, recorded our radio emissions, and left before we could respond. That's not coincidence. That's mission accomplished. Theory 8. Broken alien technology. The derelict theory. Ancient alien artifact. No longer functional. Tumbling from damage or age. Light sail or solar panel fragments. Space junk from a dead civilization. This explains weird shape, artificial design. Acceleration still has some function. No signals, it's dead. Tumbling, damaged. Trajectory, random drift. This is the saddest theory. Oumuamua as the cosmic equivalent of a message in a bottle from a dead civilization. We found evidence of aliens, but they're already gone.
All right, we've covered the science. Now let's dive into the deep end of the pool where the water is murky, the lifeguards have quit, and everyone's wearing tinfoil swimsuits. Conspiracy number 1. The government knew it was coming. The theory? World governments detected Oumuamua years before October 2017, but kept it secret while preparing. The evidence? Sudden increase in space funding 2015-2016, secret military satellite launches, underground bunker construction, elite buying land in New Zealand, convenient discovery by civilian telescope. Yes, the government that can't keep classified documents secure somehow kept an alien visit secret from thousands of astronomers worldwide. They're incompetent at everything except massive conspiracy. Makes perfect sense. Conspiracy number 2. Oumuamua deployed something while passing Earth. The theory? Oumuamua released probes, drones, or viruses while passing Earth that we didn't detect. The evidence? Unexplained satellite failures in late 2017, increase in UFO sightings afterward, strange meteors that changed direction. COVID-19 arrived exactly 2 years later. Their math, not mine. Mysterious radio signals detected since then. Oumuamua was apparently a cosmic Amazon delivery truck dropping off packages we didn't order, invisible packages that cause pandemics and UFO sightings, and probably your Wi-Fi issues. Very efficient alien logistics. Conspiracy number 3. We received a message, but it's classified. The theory? SETI detected signals from Oumuamua, but governments classified the information to prevent panic. The proof? Breakthrough Listen went silent after initial reports. Key scientists suddenly got government funding. Unusual military activity at radio telescopes. Avi Loeb's sudden media tour? Distraction? No raw data released publicly, because nothing says successful cover-up like letting the Harvard astronomy chair go on Joe Rogan to talk about alien technology. That's definitely how you keep secrets. Very CIA, much covert. Conspiracy number 4. We tried to nuke it. The theory? World powers attempted to destroy or deflect Oumuamua with nuclear weapons. The evidence? Classified missile tests in October 2017. Unusual activity at nuclear facilities. Failed satellite launches that year. Oumuamua's acceleration was from our nukes. International Space Treaty emergency meetings. We allegedly tried to nuke our first interstellar visitor, because nothing says welcome to Earth like thermonuclear weapons. It's like greeting your new neighbors with a flamethrower. Very diplomatic. Conspiracy number 5. Oumuamua is from our future. The theory? It appeared right before COVID or social upheaval, trajectory calculated to observe 2017 Earth, shape matches theoretical time travel requirements, acceleration was temporal displacement, left quickly to avoid paradoxes. Future humans sent a tumbling space cigar back in time to check on us, take photos, make sure we still exist. The temporal tourism industry must be weird in the future. Visit your ancestors, watch them argue on Twitter, see the before times. Conspiracy number 6. It came from inside the solar system. The theory? Oumuamua originated from a secret base on the far side of the Moon, Mars, or hollow Earth. The evidence? Trajectory calculations are suspect. NASA won't show certain lunar photos. Mars rovers keep breaking in certain areas. Earth's core has anomalies. Someone's hiding something somewhere. The secret moon base launched a fake interstellar object to distract us from the real conspiracy that there's a secret moon base. It's the conspiracy equivalent of setting your house on fire to distract from your dirty dishes. Conspiracy number 7. Oumuamua was a biblical sign. The theory? It was the great sign in heaven prophesied in religious texts. The connections? Shaped like a rod or staff, biblical imagery. Came from the heavens, red like blood, sorta, appeared before plague, COVID, left after delivering message. Every astronomical event is apparently the end times. Solar eclipse? End times. Comet? End times. Weird space rock? Definitely end times. We've predicted the end of the world 500 times and been wrong 500 times. But sure, this time it's real. The uncomfortable truths hidden in the crazy. Here's what is true. Some data about Oumuamua is classified. Military satellites did track it. Not all observations were made public. Some scientists signed NDAs. Governments have interstellar object protocols. The real conspiracy isn't that governments are hiding aliens, it's that they're hiding their complete inability to do anything if aliens showed up. Oumuamua revealed we have no plan, no defense, and no idea what to do except argue on Twitter.
Just when astronomers were recovering from Oumuamua trauma, the universe decided to mess with us again. On August 30, 2019, amateur astronomer Gennady Borisov in Crimea discovered our second interstellar visitor, and this one made Oumuamua look even weirder. Meet Comet Borisov, the normal one. 2I Borisov's properties. Looked exactly like a normal comet. Clear coma and tail. Obvious outgassing. Normal comet composition. No weird acceleration. No weird shape. Basically boring. Borisov was everything Oumuamua wasn't. Normal, predictable, and clearly natural. It's like the universe sent us a mystery box followed by a clearly labeled package just to make sure we knew the difference. Why Borisov makes Oumuamua more suspicious? The statistical problem. First, interstellar object, completely weird. Second, interstellar object, completely normal. This pattern doesn't make sense unless Oumuamua was special. Special means either extremely rare or artificial. If interstellar objects are randomly distributed, both should be somewhat similar. Instead, we got the cosmic equivalent of a UFO followed by a bird. That's not random, that's suspicious. The detection bias problem. Here's the unsettling math. What we should see: rocky asteroids, 90% of interstellar objects. Icy comets, 10% of interstellar objects. Weird things, less than 1% of interstellar objects. What we've seen: weird unexplainable thing, 50%. Normal comet, 50%. Normal asteroids, 0%. Either our sample size is too small, it is, our detection methods are biased, they are, or the universe is trolling us, increasingly likely. The statistics suggest we're missing something fundamental. The coming flood. With new telescopes coming online, Vera Rubin Observatory, 2024, will detect 10 to 20 interstellar objects per year. Much fainter objects visible, better tracking capability, real-time alerts. What this means? We'll solve the mystery in 5 to 10 years, or find more mysteries. Probably both. Definitely both. We're about to go from 2 interstellar objects to hundreds. If they're all normal except Oumuamua, that tells us something. If more are weird, that tells us something else. If they start spelling out messages in their trajectories, we should probably worry. Borisov's death, a normal ending. In March 2020, Borisov did what comets do. Started fragmenting near the sun, broke into pieces, released massive amounts of material, behaved exactly as predicted, died a normal comet death. Borisov came, acted normal, and died normal. It was interstellar, but unremarkable, which makes Oumuamua's weirdness even more pronounced. One weird object could be chance. One weird object followed by a normal one suggests the weird one was special.
Let's talk about what Oumuamua really means, not just for astronomy, but for our species, our philosophy, and our future. Because whether it was natural or artificial, Oumuamua changed everything. If it's natural, the cosmic humiliation. What it means? Our models of planetary formation are wrong. Interstellar space is full of weird things. We don't understand basic physics. Nature is weirder than we imagined. We're cosmically ignorant. If Oumuamua is natural, then we don't understand the universe as well as we thought. It's like studying birds for centuries, then discovering a bird that flies backwards, underwater, and glows in the dark.
Technically still a bird, but everything you knew is wrong. If it's artificial, the cosmic revelation. What it means? We're not alone. Interstellar travel is possible. Other civilizations existed. They're more advanced. They know we're here. Maybe. The questions that follow. Why didn't they stop? Are they still watching? Was it deliberate or random? Are more coming? Should we be worried? If Oumuamua was artificial, it's the most important discovery in human history. But it's also the most frustrating, like finding a single footprint in your yard. Proof someone was there, but no idea who, why, or if they're coming back. The Fermi Paradox solution nobody wants. What if Oumuamua solves the Fermi Paradox? The dark forest hypothesis. Civilizations stay quiet to survive. Oumuamua was a silent probe. It observed but didn't communicate. This is how civilizations explore safely. We should be very, very quiet. If Oumuamua was an alien probe that deliberately stayed silent, that's terrifying. It suggests the galaxy is full of civilizations that have learned not to talk to each other. And we're out here broadcasting hello like idiots at a library full of assassins. How Oumuamua changed our space programs. Immediate changes. Breakthrough Listen got more funding. New interstellar object protocols created. Space Force interest increased. Planetary defense prioritized. SETI taken more seriously. Project Lyra. Proposed mission to catch up to Oumuamua. Would take 20 to 30 years to reach. Requires technology we don't have. Estimated cost, $1+ billion. Probably won't happen. We want to chase Oumuamua with a spacecraft that doesn't exist, using technology we haven't invented, to reach it in 30 years when everyone involved is retired or dead. Very realistic. Much planning. The cultural earthquake. How Oumuamua changed culture? Scientific papers, 1,000+ published. Books written, dozens. Movies inspired, several in production. Conspiracy theories, countless. Public interest in astronomy increased 300%. Oumuamua did more for astronomy public relations than 50 years of NASA missions. Nothing gets people interested in space like potential aliens, even potential aliens that ignored us and left. The 3 futures we face. Future 1, the boring one. All future interstellar objects are normal. Oumuamua was a fluke. We figure out the physics, mystery solved, everyone disappointed. Future 2, the weird one. More Oumuamua-like objects detected. Physics gets increasingly broken. New theories required. Universe stranger than imagined. Scientists very confused. Future 3, the terrifying one. Next object slows down, or sends signals, or changes course toward Earth, or isn't alone. First contact, ready or not. We're waiting to see which future we're in. Every new interstellar object is a dice roll, natural or artificial, passing by or stopping to chat.
The universe is about to answer questions we're not sure we want answered.
Oumuamua didn't just challenge our physics, it challenged our philosophy. It forced us to confront questions we'd been avoiding. Questions about our place in the universe, our readiness for contact, and our cosmic significance. The readiness paradox. How humanity responded to potential first contact. Scientists argued publicly. Governments did nothing useful. Media spread misinformation. Public panicked or ignored it. Religion wasn't sure what to think. Internet made memes. We've been preparing for first contact for decades. We have protocols, committees, and plans. But when a potential alien probe showed up, we basically just screamed at each other on Twitter. Very ready, much prepared. Wow. The arrogance check. What Oumuamua taught us. We can't catch interstellar objects. We can't properly study them. We can't agree what they are. We can't stop them if hostile. We can't even see them coming usually. Oumuamua flew through our solar system like a cosmic middle finger to human capability. We couldn't catch it, barely saw it, and argued about it while it left. If aliens were testing our readiness, we failed spectacularly. The scientific civil war. Oumuamua split science into camps. Team Natural. Most established astronomers insisted on natural explanation, accused others of sensationalism, fought dirty in peer review, won the institutional battle. Team Maybe Artificial. Some respected scientists, open to artificial hypothesis, professionally punished, publicly mocked. History might vindicate them. Scientists who pride themselves on objectivity turned into tribal warriors defending their worldview. Careers were damaged, friendships ended, and academia showed its ugly side, all over a space rock that might be a space rock. The Loeb lesson, the cost of thinking different. What happened to Avi Loeb? Lost astronomy department chair position. Colleagues publicly attacked him. Funding became harder to get, labeled unscientific. Media painted him as fringe, but also wrote best-selling book, started new research initiative, got private funding, influenced public opinion, might be vindicated eventually. Loeb paid a price for suggesting Oumuamua might be artificial. The scientific community that claims to value open inquiry punished him for inquiring too openly. It's like Galileo all over again, except this time the Earth might actually be the center of someone's survey mission. The public's cosmic awakening. How regular people responded. Google searches for aliens increased 10,000%. Telescope sales spiked. Astronomy courses filled up. SETI donations increased. Science fiction had a renaissance. Oumuamua did something decades of science education couldn't. It made people look up, not at their phones, but at the sky. For a brief moment, humanity remembered we're on a rock in space and there might be others. The existential questions we can't avoid. If we're alone, why is the universe so empty? Is intelligence that rare? Are we the only witnesses to cosmic beauty? Do we have a responsibility to spread life? Is the universe ultimately meaningless? If we're not alone, why the silence? Are they avoiding us? Are we being watched? Are we ready for contact? What do they know that we don't? Oumuamua forced us to actually think about these questions instead of treating them as thought experiments. It's one thing to wonder if we're alone. It's another to have potential evidence fly past while you're figuring it out. The motivation problem. Oumuamua should have inspired massive space program funding, international cooperation, detection system development, interstellar mission planning, unity in facing cosmic unknown. What actually happened? Brief media cycle, some academic papers, lots of arguments, no significant policy changes. Back to normal in 6 months. We had potential first contact and responded by doing essentially nothing. No Apollo program for interstellar objects, no Manhattan Project for detection systems, no global cooperation for cosmic defense, just memes and arguments. The generational impact. Kids who grew up with Oumuamua. First generation knowing interstellar objects exist, comfortable with possibility of aliens, less Earth-centric worldview, more interested in space, might be the ones who solve the mystery. There are kids who learned about Oumuamua in school who will become the scientists that detect the next one, or the engineers who build ships to catch them, or the diplomats who make first contact. Oumuamua planted seeds that won't grow for decades.
So, here we are, minutes later, and we still don't know what Oumuamua was. But maybe that's the point. Maybe the mystery is more valuable than the answer. What we know for certain. The facts. Oumuamua was from another star system. It had properties we can't fully explain. It accelerated unnaturally. It's gone forever. More are coming. The impact changed astronomy forever,
challenged our assumptions, divided the scientific community, woke up public interest, prepared us for what's next. Whether Oumuamua was a weird rock or alien technology doesn't matter as much as what it did to us. It made us look outward. It made us question. It made us realize we're not ready for what's out there. The eternal question. Oumuamua is now beyond Neptune's orbit. In 10,000 years, it'll be in another star system. In 1,000,000 years, it might pass another civilization that will ask the same questions we asked. What is it? Where did it come from? Is it natural? Is someone out there? Are we alone? Maybe that's Oumuamua's purpose, not to make contact, but to make civilizations wonder, to plant the seed of cosmic awareness, to say you're not alone without saying anything at all. Or maybe it's just a weird space rock and we're projecting our cosmic loneliness onto tumbling debris. The warning. If Oumuamua taught us anything, it's this. The universe doesn't care if we're ready. Interstellar visitors won't wait for us to prepare. We're more vulnerable than we thought. We're less united than we need to be. The next one might not just pass by. We have maybe 5 to 10 years before the Vera Rubin Observatory starts detecting interstellar objects regularly. Some will be normal. Some might be weird. One might slow down. Are we ready? No. Will we be ready? Probably not. Does the universe care? Absolutely not. The call to action. What you can do. Support asteroid detection programs. Learn about space and science. Push for international cooperation. Stay informed but skeptical. Look up occasionally. What humanity must do. Build better detection systems. Develop interception capability. Create contact protocols. Unite as a species. Grow up, cosmically speaking. Oumuamua was either our first contact with alien technology or our first lesson in cosmic humility. Either way, it was a test, and we failed. But failure is how we learn, and we'd better learn fast, because Oumuamua was called Scout for a reason. Scouts usually report back, and what comes after scouts is rarely friendly. On October 19, 2017, humanity discovered we're not as alone as we thought. Something from another star visited our home. It saw us, it passed us, it left us with more questions than answers. Oumuamua means scout from afar arriving first. First. Not only, not last, first. Which raises the question that should keep you up at night. If Oumuamua was first, what's second? What's coming? And will we be ready when it arrives? Right now, as you watch this, there are probably dozens of interstellar objects passing through our solar system. We can't see them, we don't know they're there, but they're passing by or passing through, or watching. Oumuamua opened a door we can't close. We now know interstellar visitors are real. We know they can be weird. We know they can behave in ways that challenge our physics. What we don't know is whether one has already decided to stay. Oumuamua status, 8.5 billion kilometers from Earth and accelerating. Next interstellar object, unknown. Humanity's readiness level, insufficient. Time to prepare, running out. They called it Scout. Scouts report back. What did it report? And to whom? Sleep well.